Hi, welcome to Make 2 Explore. So in our previous video about ESP ZeroCode, we have seen how to get started with this platform and how to create your own Matter-enabled IoT product. We have also seen how to flash the ESP32 boards with different ZeroCode product samples and test them using ESP Launchpad and Amazon Alexa app. In this video, let's see the detailed view about text mode configuration in ZeroCode. We will understand it using an example. For that, we will create custom ZeroCode product for channel plug board. Then we will also see its demo with different appliances. So let's get started. Please note, this tutorial is divided into two parts. In first part, we will see some theory like circuit diagram and introduction to text mode configuration of ESP ZeroCode. And in second part, we will see practical demonstration. So we suggest you to watch both the videos for proper understanding of text mode configuration in ESP ZeroCode product development. So here is the ESP ZeroCode platform. Let's first quickly create one sample product and go to configuration step. We will use product sample named plug. So we know that there are two modes are available in ZeroCode for product configuration. One is graphical mode, which we have seen in earlier sessions. Now let's explore the text mode. So you can see currently it is still in development phase, means the beta phase. Okay? In this mode, you can write your own configuration. As they said here, create a custom configuration for your product by specifying the desired settings in JSON format. So you can see, this is a default JSON file for plug device product. Here you can see, there are different objects are defined, like for drivers, product, or drivers common functionalities, and test mode. Objects are nothing but collection of key value pairs. Keys are in strings, and values can be any valid JSON data types like object, string, array, number, boolean, and null. Every key here in these objects represents some configuration, like here, for example, for this product plug, we require 3 GPIO pins. Let me show you the circuit diagram again in graphical mode. So you can see, for this product named plug, we have to specify 3 GPIO pins. One for input button, one for output relay, and another for indicator LED. So in JSON file, you will see 3 different IDs for these 3 different pin functions. And their type will be driver.button, driver.relay, and driver.LED, respectively. You can learn more about these keys by just hovering over them here in this editor window. Its related information will be shown here as you hover mouse pointer over them. So for key named ID, you can see as they say here, this must be unique for each driver object created. Make sure to use the correct driver ID in the other sections. Similarly, configuration for GPIO button, applicable only if EZC driver PIO is selected. Then for GPIO number, input GPIO for the driver. Range of values depend on the chip. Then, very interesting, button active level. When is the input detected? Is it active high or active low? So here, 0 means active low. Here the input is detected when the input pin is connected to ground, and 1 means active high. The input is detected when the input pin is connected to VCC power. So sometimes you need to change this active level to active high. For example, in our case, indicator LED will get turned on, only if we provide logic high to it. So what do you think how we should update its active level? Yes, you are right. We have to make it active level high. So here you can verify it. the light active level. When is the output turned on? If we put 0, the output of pin will be 0 volt. If we put 1, the output of pin will be VCC. Hence, it will glow the LED. Likewise, these are common configuration for LED driver. For example, how LEDs should behave when these events get triggered. When should the setup mode activated means when we try to commission the device, it should blink at 4000 rate. Here, color is not valid for our case, since we are using generic single color LEDs. So there are a lot of events, as you can see. Here you can go through them for more details. Then next important object is product specifications and configurations. So you can see, though the product is plug, its type is socket. And in this, there are 3 drivers which we have seen earlier. Input means button, output means relay, and indicator, which is LED. Now pay attention on this data model. This is data model for simple on-off sockets. For default power state, it is on when provided with 1, and it is off when provided with 0. But for the boot state, that is power state on boot up, you can set from these values. There is also an option to remember previous value, means the previous state. So if you set this option enable, then even though power goes off, systems still remember the previous states or values. This is awesome, isn't it? Then next are test modes config, for different modes like common, BLE, and socket. Okay, alright, so this is all about the JSON formatting. Now, let's move forward. Please note, this is just tip of an iceberg, which we have explained about JSON-based configuration. For advanced mode config, you need to go through documentation of this product. Look deeply through each and every parameter as per custom design in your mind. Now, suppose you want a custom product design, how you can set up device with your own configurations. You must have been wondering that where you will get the documentation and details about these different parameters, right? So for that, go to top right of this configure page. You will see this option, set up device with your own configuration. Here, as they say, with the advanced text mode, lets you build your own configuration for your device. You can change default settings as per your requirements, or create an entirely new configuration. Okay, now let me show you the product documentation. For that, you can click on this button. Here you will find this button named like Explore Product Configuration. If you click on it, new window will get open. Like this. You can also open it in new tab for better view. So this is ESP ZeroCode product documentation. Please read the note they have given here. The advanced text mode for JSON configuration offers a lot of flexibility, which might result in the device not working as expected because of some mismatch in configurations. You should have to evaluate and ensure that things work correctly on your end. You can contact them on this email ID for any questions or help. So these all are configurations and different parameter settings. This is a very long list. Let's understand it in brief. So as we explained earlier, the ZeroCode product configurations are usually divided into these 5 sections: pre-driver, driver, product common, product, and test mode. First is the pre-driver section. These are the things which are initialized even before the device drivers are initialized. This is done at the very start of the boot up. This includes power-related and communication-related initializations. Then comes the driver section. The drivers are initialized at this stage. This includes the lower-level drivers like button, LED, etc. They are then used or linked later in the configuration based on their driver IDs. Next is product common section. This includes things which are common to the product as a whole. The drivers which are initialized before are used here. Then next section is about actual product. It represents the actual product and how it is shown in the ecosystems. Example, to create a 2-channel socket, the socket must be present 2 times here. The drivers which are initialized before are used here. And last section is test mode. These initialize the test modes that can be performed in the factory during manufacturing. If enabled, they need to be marked as completed before the device leaves the factory. Until then, the device checks for the trigger for the test modes on boot up. So here is the example which we have seen earlier. Then next important point is the properties. In this table, you will see overview with respect to configuration sections, their descriptions, their possible values, defaults, data types, and their requirement. For example, you can see this section of config version is mandatory in each product config. It is of integer type, and its possible value is 3. We have seen this in the example, right? So in this way, from this onwards, in this documentation, you will find different sections, configs, their properties, and subsequent examples, JSON codes. This is a very vast document. Use it smartly to seek your desired info. Now, one more very important thing. Please pay attention. Suppose once you edited or modified the default JSON, then whatever new configurations you do in your JSON file, you have to validate them. You can do it by clicking on this Save and Validate button. This will check your configuration and let you know is it valid or it has any errors. It's just like compiling your JSON. If there are any mismatch in your config, you will get error here like this, and it will also notify you about the cause. Okay, now in this video, for the sake of demo, we are going to modify the plug product. The ZeroCode template is for only one plug socket combo. In order to create custom example, we will create 3 more sockets in that device and control the 4-channel relay board. Let me show you the circuit diagram. So you can see in this circuit diagram, we're going to use ESP32C3 board for this experiment. Then we will connect this 4-channel 5 volts relay board, which can be used to switch both AC and DC loads. We're going to use 2 AC bulbs and 2 DC appliances. Among them, one is small 5 volts DC exhaust fan, and other is small 5 volts DC submersible pump. There will be 4 push buttons, which will be used to control these loads manually. And these 4 LEDs are for the indication purpose. Like we did in our earlier videos, we're going to use Alexa app and Smart Speaker Echo for device commissioning and control. If you want to refer the circuit diagram, you will get it on our GitHub repo. Links will be shared in the description. This is in high-resolution image, and all connections are in color coding. Properly commented, you can easily trace it. Before going to update the JSON file, let's quickly break down what smart plugs, sockets, switches, and outlets are, since people often use these terms interchangeably, which can get confusing. Smart plugs, such as shown in these pictures, are designed to be plugged into standard electrical outlets, and they connect to your smartphone via Bluetooth or Wi-Fi, allowing you to turn power to the plug on and off remotely in the companion app. As you can see, they comes with this plug socket combo packs. So in this case, the main function of this plug end is just to connect the device to power. You can plug electronic devices like a lamp or fan into your smart plug for remote control. Some of the benefits are that you can set it to an automatic timer or schedule, and also control it through a smart voice assistant like Alexa or Google Assistant. However, one of the main benefits of smart plugs are the quick and simple installation as well as the portability. These are plug-and-play devices, so you don't have to worry about messing around with electrical wiring to install them. Today's most smart plugs are also quite budget-friendly, costing less than $20. Smart outlets look like as shown in these pictures. These are designed to replace the regular outlets completely. Here, the concept is still the same. You plug electronics into the outlet and can control them via your smartphone. But smart outlets are hardwired directly into your home's electrical system. To install a smart outlet, you have to turn off the circuit, disconnect the wires from the existing outlet, and reattach all the wires to the smart outlet. Then comes smart switches, which looks like as shown in these pictures. Here, the concept is somewhat different. These devices usually comes without any sockets. There are only switchboards. You have to replace your traditional switchboards with smart switches. They get directly hardwired into your home's electrical system. To install a smart switch, you have to turn off the circuit, disconnect the wires from the existing board, and reattach all the wires to the smart switchboard. Alright, so this was all about these smart devices. If you go through the list of zero-code devices, you can see there are different types of devices comes under this plug, socket, and switch category. Like, for example, you can see the device or the product template, which we have used earlier. And again, we are going to modify and make custom product using it. That is this plug. It comes in both category, plug as well as socket, isn't it? Then you can see similar kind of device, this extension board. Comes with 4-channel GPIO driver, means with 4 sockets. Then here you can also see switchboards, like 4-channel wall-mounted switch, 2-channel wall-mounted switch, retrofit switch, and so on. This was the first part of the tutorial. In next part, we will see practical demonstration. Please stay tuned. Thank you very much for your support.